Good evening, champs! Welcome to 90 Plus, India's first animated live tuition. Yes, good evening. Where are you guys? Yes, I have messages. No one is here? Yes, good evening, good evening. Hi, hello. How are you doing? Are you all here? So, are my kids here? Yes, good evening, good evening. Yes, so did you have your evening tea and snacks and all those? Yes, right? Yes, good evening, yes. And you're ready to learn chemistry. Yes, we are meeting after a long week. Ale? We're meeting after a long 1 week and the chapter it is chapter number 4, structure of the atom, right? So, before starting, let me ask any new students in the class? New students, okay, dog. Can you please raise your hands? New students, can you please raise your hands? No new students?
Yes.
Shraddha. Okay, Shraddha is a new student. So, Shraddha, the structure of an atom is starting. Okay, and in the class, this is our second class. And our YouTube live, and this is also a YouTube live. Okay, we are going live on YouTube as well. So if you want to see the previous lecture, you can go to our channel 90 Plus CBSE. Okay, adili chapter in the first part. This is our second part. Okay, yes. So only Shraddha, right? Shraddha is only new students. New student. No one else. Okay. Yes. Very good. Now, before starting, you can all turn on your cameras. Okay. Loud camera on and show me your sweet smiling faces. Okay, perfect. And this should be an interactive session. Okay, you should all comment the answers because in another session it's really interesting. Okay, electronic configuration it's awesome. All right, yes. So in today's session, yes. Good evening. Yes. So in today's session, we are going to study Bohr's model of an atom. Okay, Bohr in the atomic model. Okay, then we learn how these electrons are distributed inside an atom. Okay, electrons arranged. Okay, then our last topic will be valency. Valency we already studied in our third chapter, right? But in this chapter, we'll study it a bit more, in bit more detail, and we'll study how to find the valency of certain atoms. All right. Yes. So these are the 3 important topics that we are going to cover in this session, and you can expect around 3 to 4 marks from this area. Okay, 3 to 4 marks. All ready? Okay, now shall I start the class? Okay, please give me a fire emoji or heart emoji so that we can start the session. Yes, everyone, you can give me a heart. I got heart and fire. Very good. And I can see a knife. Why? Who's that? Why a knife? Alright. Yes. Thank you so much. Yes, thanks so much for your love. So before starting, let me ask you a quick question. Everyone, you should comment, okay? Yeah, that's okay. I was just kidding. Okay, yes. So, who was the first scientist to propose a structure for, or to propose a model for an atom? Who was the first scientist? This is not the starting hour. This is our second class, okay? It is our second class of structure of an atom. Yes. Was it Dalton? No. Devanarayanan, you are correct. Yes. Adityan, yes. Now all of you are commenting the right answer. It was J.J. Thomson, right? And we study Thomson's model of an atom. And what was that model also called? J.J. Thomson model was also known as, it was known as watermelon model, Christmas pudding model. Yes, and we saw the limitations as well. Then there came a second scientist and his name was Rutherford, and he put forward nuclear model of an atom. our model of an atom. Yes, very good, very good. Now, and Rutherford model, there were some limitations, right? Yes. What was the limitation? Do you remember? He proved that there is a nucleus inside an atom. Atomത്തിനുള്ളിൽ ഒരു nucleus ഉണ്ട്, and he said that the size of the nucleus is much smaller than that of the atom. ആറ്റത്തിനേക്കാൾ ചെറുതാണ് ന്യൂക്ലിയസിന്റെ size എന്ന് പറഞ്ഞു. And the positive charge, so yes, and the positive charge is found inside this nucleus. Alle? And electrons are revolving around it. Yes. So, a postulate the problem. The revolution of electrons. Rest all was what? Okay. But the orbital revolution. A revolution of electrons, I know. Why? Because when these charged particles, when they travel in a circular motion, what will happen is that they will emit energy. Okay, radiations emitting. So, no, you will not have chapter test. Okay, yes, not today. Yes, so they will emit radiations. Radiations emit the last, they will lose all their energy and they will collide into the nucleus. When electron nucleus collide, what happens? The atom will become unstable. Okay, the atom will become unstable. So, Rutherford in the drawback in a cover there came another scientist. His name was Niels Bohr. Okay, Niels Bohr. So, Niels Bohr was a student of Rutherford. He was working in Rutherford's laboratory only. Okay, and Bohr he put forward some theory in order to overcome the drawbacks of Rutherford. And he proposed a model for an atom. Alright. Yes. And now let's see in detail what are the postulates of Niels Bohr. Okay. Yes, Niels Bohr model postulates. First, now you can put down your pen. No need to write anything. Okay. Yes. Bohr said that there are certain orbits inside an atom. Okay. There are certain orbits. That electrons revolve and there are some special paths. These paths he called it as orbits. Okay, now inside an atom there are some special orbits called discrete orbits. Okay, discrete orbits in the discrete orbits you can find electrons. Okay, yes, so that was his first postulate. Only certain special orbits known as discrete orbits of electrons are allowed inside an atom. Or atomത്തിനുള്ളിൽ കുറച്ച് orbits ഉണ്ട്, discrete orbits ഉണ്ട്. ഈ orbitന്റെ ഉള്ളിലാണ് ആരുള്ളത്? Electrons ഉള്ളത്. Okay, is it clear? Is it clear? Yes, any doubts with the first postulate? Yes. Now, what do you mean by discrete orbit? Discrete orbit in this orbit, the energy will be fixed. Okay, energy fixed ആയിട്ടുള്ള കുറച്ച് orbits ആയിരിക്കും. ഈ fixed energy orbitals the electrons will be present. Okay, ഈ orbits electrons they will be revolving. Okay, this is the first postulate. Now you can write it down. Okay, you can take a screenshot first and then start writing. Niranjana, you will not have chapter test today. Okay, in the chapter test illa. Okay, so are you all writing it down? I can see some of them are not writing it down. You can write it. Okay, yes, very good. Yes. Okay, so this was his first postulate. Now, let's move on to the second postulate. Okay, he said that the electrons, while they are revolving inside this discrete orbits, the electrons will not radiate any energy. Electrons energy no lose, they will not gain energy. The energy will be constant. Okay, energy in the it remains constant. So while revolving in discrete orbits, the electrons will not emit radiations. അവര് energy നെ എന്ത് ചെയ്യില്ല, release ചെയ്യില്ല. Okay. Yes. So that is what he said. Now we said that we have different orbits, right? Orbits, or these orbits are also known as shells. Okay. These shells have fixed amount of energy. First shell, it will have a fixed amount of energy, and the second one, third one, and it goes on. So since they are all associated with some sort of energy, these circular orbits or shells are also known as energy levels. Okay, ഈ orbitsനെയും shellsനെയും energy levels എന്നും എന്ത് ചെയ്യും, അറിയപ്പെടും. Okay, is it clear? These are the important postulates of Bohr's model of an atom. Okay, so what was the first postulate? What was the first postulate? Yes, there are some special orbits inside an atom called discrete orbits. Okay, in discrete orbits the electrons are present. Now, while these electrons are revolving in these discrete orbits, it will not emit what? Energy. It will not produce radiations. Okay, and these shells or orbits has got fixed energies. Okay, that is why they are also known as energy levels. അതുകൊണ്ടാണ് അവരെ energy levels എന്നും വിളിക്കുന്നത്. Okay, is it clear? I hope you've written this as well. So did you write down the two postulates? Very good, very good. So can I ask a question then? Did you write it down? Did you write it down? Yes. Okay. Yes, I can see some hearts as well. Alright, ma'am. Then let's ask her.
Mayuga.
Yes, Mayuga. Hi.
Hello, ma'am.
Yes, so Mayuga, can you tell me the first postulate of Bohr's model?
That so there are certain orbits called discrete orbits around the nucleus of the atom.
Yeah.
In which the electrons are revolving.
Yeah, revolving. All right. Now, the second one, ma'am.
Remal.
Remal. Hi, Remal.
Hi, good evening. Good
Yes.
evening, ma'am.
Good evening. So, can you please tell me the second postulate?
Yes.
Yeah.
While revolving in discrete orbits, the electrons do not radiate
Yes.
energy.
Very good. Very good. So that was a major drawback. The revolution of electron was a major drawback of Rutherford's model. Alle? Bohr said that there are some fixed shells or orbits in which the energy is constant. So when these electrons revolve in these orbits, it will not radiate energy. So that problem is solved. Okay. Now let's see a closer look on what Bohr's model of an atom. Yes. So what you see here, this green color round thing, is nothing but the nucleus of an atom. Okay, this is the nucleus of the atom. So at the center there will be a nucleus. Now these white color circular parts, these are the orbits or shells. Okay, these rings are nothing but the orbits or shells. Now the very first shell closer to the nucleus, I mean this one, the very first shell is named as the K shell. Okay, it is known as what? K shell. Okay, now the second one is the L shell. Second one is the L shell. Alright, third one will be M shell. M shell. And this one is the N shell, and it can go on. Okay, it goes on. Alright, now the very first shell is the K shell, then comes L, M and N. Is it clear? Yes. Or else you can say that this is the first shell. N represents a number of shells. Okay, K shell is also known as the first shell. L shell is the second shell. Okay, L is the second shell, M is the third shell, and N is the fourth shell, and it goes on. Is it clear? Yes, this is a rough idea of Bohr's model of an atom. There will be a nucleus in the center, and there will be some closed parts called orbits or shells. And the first shell is the K shell. Okay, first shell, K shell, then L, M, N, and it goes on depending upon the atom. Okay, yes, and they said that these electrons, these orbits has got some fixed energy. Okay, K shell is a fixed energy. L shell is a fixed energy. So these are also known as what? Energy levels. Okay, these are also known as energy levels. Yes, let's see a quick animation. Okay, so again we have our first animation so that you get a more clear idea. Okay. Okay, yes. Yes. Now, see, this is like Bohr's model. Okay, in the center you have a nucleus. In nucleus, why is it given a positive charge there? Because we already know that the positively charged protons, okay, the positively charged protons are found where? Inside the nucleus. So that is nothing but a nucleus. A nucleus contains the positively charged protons inside it. Alright. Now the electrons. Okay, what do these electrons do? Electrons is found outside the nucleus in spatial parts called orbits or shells. Yes, sir, right. Yes. Yes, the electrons are revolving in orbits. And we have 1, 2, 3 shells here. Okay. Yes, these shells are also known as K shell, L shell, and M shell. Now, we already said that these shells has got certain like fixed energies. So, these are also known as energy levels. And when we move away from the nucleus, okay, when we move away from the nucleus, the energy will increase. That is, K will have a minimum energy, and when you move to the L shell, its energy will increase. When you go to the third shell, that is the M shell, energy in the name increasing, and it continues. Okay, when you move away from the nucleus, energy will increase. Is it clear? Okay, Ayo? Yes, very good. Yes, sir, thank you so much. Now, so we discussed about protons and electrons. Now, there was another scientist called James Chadwick. Okay, James Chadwick, he identified a third subatomic particle. Okay, we already discussed about neutrons in the previous, like our first session, but still, he identified the presence of a third subatomic particle. Okay, and he named it as neutron. Okay, he named it as neutron. Now, how did he find it? It is not there for you to study, but still I'll tell. He bombarded beryllium. Okay. Okay. He bombarded beryllium with alpha particles. Okay. Beryllium alpha particle bombard cheyidappo he found the presence like some neutral, charge neutral particles emit and these neutral particles had a mass which is very close to the mass of protons. Okay, protons in the mass, same mass, but charge one particle presence Chadwick detected, and he named it as neutron. Okay, he named it as neutron. Now, how will you represent neutron? Small n. Okay, small n. Now, the mass of the neutron is nearly equal to that of mass of the proton. Proton mass in there, it was 1 u, right? It was 1 u. So, we can say that the mass of the neutron will also be equal to what? 1 unit. Okay, 1 unit. Now, what about the charge of the neutron? Charge of the neutron. We already said that it's a neutral particle. So, it will not have any charge. Yes, very good. It will not have any charge. Alright. Yes. So, we have got total of 3 subatomic particles. What our Dalton said was, Dalton എന്താ പറഞ്ഞത്? Atom. Atomത്തിന് further cannot be divided. Okay. Atomത്തിന് further ആയിട്ട് എന്ത് ചെയ്യാൻ പറ്റില്ല? Divide ചെയ്യാൻ പറ്റില്ല. But we found the existence of 3 subatomic particles, that is electron, proton and neutron. So what are the 3 subatomic particles that you have to study? Everyone say it along with me. It is electron, proton and neutron. Very good, sir. Now where are these subatomic particles seen inside an atom? Don't worry, we have an animation. So can we have our second animation? Neutrons have a neutral charge. Yes, sir, surprise okke kalanju. Starting with the sir. Yes. All right. Now, if this is an atom has got 3 subatomic particles. Yes, sir. You can play it. Yes. Stop. Yes. All right. We have got a proton, an electron, and a neutron. Now, where can you find these inside an atom? So, now, proton and neutron, like both of them are found inside the nucleus. Okay, so protons and neutrons are found inside the nucleus, and outside the nucleus the electrons are revolving in orbits or shells. Yes, sir, please wait. Yes, the electrons are revolving just outside the nucleus in orbits or shells. So is it clear? Protons എവിടെയാണ്, neutrons എവിടെയാണ്, electrons എവിടെയാണ്? Clear ആയോ? Is it clear? Okay, sir, you can remove the animation. Yes, now let me ask a question, a quick question. Yes, ma'am.
Rena.
Yes, Rena. Hi. Hi. So Rena, tell me, what are the 3 subatomic particles that we just studied? Can you name them?
Electron, proton,
Yes.
neutron.
Very good. We have electron, proton and neutron. Now let me ask you another question. Can you tell their charges? What about the charges? What is the charge of proton? What is the charge of electron? And what about neutron? Or just tell me the charge of neutron.
Neutron.
Sorry.
Positive.
I mean, I'm asking about neutron. Charge of neutron.
Negative charge.
Is it negative? Negative or no? We just said it. It's there in that
Positive,
word
sir.
only. Neutron. Neutron. Just think. Okay, so who wants to help? Who is it, ma'am? Who is it? Phoebe. Yes, who wants to help Phoebe? Yes, next one, ma'am. Okay, next one is Phoebe. Yes, Phoebe.
Yes.
Yes, so Phoebe, tell me, what is the charge of a neutron?
Positive.
Positive. Is it?
Negative.
Positive or
Sorry,
negative?
neutral.
What is it?
Neutral.
Neutral. Positive പറഞ്ഞ negative പറഞ്ഞ neutral പറഞ്ഞ ഏതെങ്കിലും ഒന്ന് ഓർമ്മിക്ക്. Which one? You said the all like available ആയിട്ടുള്ള എല്ലാ ഓപ്ഷൻസും പറഞ്ഞു. Which one? Last but not the least.
Neutral.
Neutral. ഉറപ്പിച്ചു.
Um,
Okay. So what about the charge of an electron?
negative.
Negative? Apa proton? What about proton?
Positive.
Very good. Okay. So proton is positively charged. Neutron is neutral. It does not have any charge, and electron is negatively charged. Ma'am, who was the one we asked the first question? Rena. Rena. നമുക്കപ്പം ഈ പാർട്ടിക്കിൾസിന്റെ ചാർജ് ലൈക്ക് ഒരു 3 times എഴുതി പഠിച്ചാലോ? What do you think? Rana is ready. She's showing me thumbs up. Okay. So please write it 3 times. Okay. The charge of proton, neutron and electron. Alright, yes. So now let me ask another question. What about the mass of these subatomic particles? Neutron the mass is there. So let's ask someone else. Diana. Hi Diana. Hi, can you please unmute? Others you can comment it. Yes, very good. I'm seeing the comments. Okay, very good, very good. Yes, very good. Yes, Diana, are you there? Yes. Diana is here and tell me. Hi. Like, do you have any network issues, Diana? Okay. No, neutron is not positive. Okay, neutron does not have any charge. It is chargeless. Now, yes, let's call someone else. Sri Lakshmi, hi. Hi, Sri Lakshmi. Okay, but you're not audible. Hi. Sri Lakshmi, you're not audible. What happened? Yes. Like, do you have any network issues? Okay, I can't hear her. Yeah, we'll get back to you. Okay, don't worry. Okay, so the mass of the neutron is nearly equal to that of proton. Okay, yes. Now I'll show you a table. This table is quite important. Okay, yes. The three subatomic particles are, we have proton, electron and neutron. First, you have to study the symbols. How will you represent proton? P plus. Okay, P plus. This is how you represent proton. Now what about electron? Electron, E minus. Okay, electron is E minus. Neutron. Neutron you can represent here, small n. All of these are small letters. Okay, they should be in small letters. Small p, positive. Small e with a negative charge and small n. Now, what about the mass? What about mass? We know that proton and neutron has got a mass of 1 unit. Okay, mass of 1 unit. And we already discussed in our previous session that mass of the electron is very less. Okay, വളരെ less ആയതുകൊണ്ട് നമുക്ക് എന്ത് ചെയ്യാം? We can just ignore it. We can say that the mass of the electron is negligible. We are ignoring. It is not at all of importance. Okay, no importance at all because it's very less. Now, what about the charge? Proton has got a positive charge. Positive 1. Now, what about electron? It is negative 1. Okay. And neutron, it is chargeless. So, you can write 0. Okay, it is chargeless. Alright. Yes. Now, the position. Where is it found? Proton is seen inside the nucleus. Okay, it is seen inside the nucleus. Now, what about electron? Electron, it is outside the nucleus. Okay, electron is found revolving outside the nucleus in shells, right? Yes. Now, what about neutron? Neutron is also found inside the nucleus along with proton. Is it clear? Okay, did you take a screenshot? Alright, yes. So, I'm changing the slide, okay? Now, so we already found that since the proton and neutron has got mass and the mass of electron is negligible, we can say that the mass of an atom will be equal to the masses of neutrons and protons present. Okay, Ale? See, the subatomic particles present inside an atom, it is proton, electron and neutron, right? We said that the mass of electron is negligible. Okay, so we are neglecting the mass of electron here. We have proton and we have neutron. So we can say that one atom's mass it will be equal to the mass of proton plus mass of neutron. Now this is important. Okay, this is important. You should have this idea in your mind. All right. So what is mass of an atom? Mass of an atom will be equal to mass of proton and mass of neutron here. Alright? Yes, you can write this down or you can note this down. Mass of an atom is a sum of masses of neutrons and protons present in the nucleus. Okay. Electron. What is the symbol of electron? It is E minus. Okay. Alright. Now, is the slide clear? Can I change the slide? You can show a thumbs up. Yes, very good, very good. Okay, I'm changing the slide. Now, the electrons Bohr said that the electrons are revolving outside the nucleus in some orbits or shells. But how are these electrons distributed? Electrons arrange. We are going to study about the arrangement of electrons. Okay, now the arrangement of electrons was suggested by two scientists. We have Bohr and Bury. Okay, Bohr and Bury. These put forward some rules. Okay, rules rules prakaram electrons shells arrange. Okay, so shall we see the rules? Alright, now the very first rule is, yes, the very first rule is the maximum number of electrons present in a shell is given by the formula 2n square. Okay, 2n square, where n is the number of orbit or the shell or the energy level index. Simple. Okay, so the first point, or shell accommodate maximum number of electrons. Okay, we have a formula, and that formula is 2n square. Okay, it is 2n square, where n is the number of shell. Okay, number of shell or the number of orbit. We name some shells, right? K, L, M, N shells in a name. So if it is K, number of shells, it is the first shell, right? So n will become 1. So the next shell, which is the L shell, n will become 2. Let's see that in detail. Okay, yes. So this was Bohr's model. In the middle, you've got a nucleus, and this is our first shell, which is the K shell, right? This is the first shell, which is K shell. First shell, right? Now, first shell maximum electrons in they put forward a formula. Okay, they gave us a formula, and that formula is 2n square. Okay, everyone put down your pen. Everyone, you can put down your pen. I'll give time. Okay, yes, it is 2n square. First shell electrons accommodate. Okay, yes. So K shell n will be 1 because K is our first shell, right? Yes. So in order to find the maximum number of electrons that can be accommodated in the K shell, what you have to do is just put 1 for n. Okay, that is 2 into 1 square. What is 2 into 1 square? That is 2. So in the K shell, that is in the first shell, the maximum amount of electrons that can be accommodated is 2. Random electrons. Okay, only 2 electrons are possible in the first shell. Is it clear? If it is clear, you can write it down. So in the K shell, the maximum number of electrons that can be accommodated is 2. Okay. Yes. Now we are going to find out the number of electrons, maximum number of electrons that is possible in the second shell, that is our L shell. Okay. Yes. This is our second shell, right? L shell. Since it is a second shell, n will be what? N will be equal to 2. Now, shall we find the maximum number of electrons? It is given by the formula 2 into n square, and now substitute 2 for n. Okay, so we'll get 2 into 2 square. That will be what? 2 square is 4. What is 4 into 2? It is 8. Okay, 8. Now, the third shell is the M shell, right? Yes, the third shell is the M shell. Now, quickly find out the maximum number of electrons that can be accommodated in the M shell. Very good, Shraddha. Very good. Yes, Arunima. Bhadra, check that again. Ah, yes. Very good. Very good. You all are commending. Devanarayan, why 0? Why 0? How did you get 0? Come on, type it. Like, I want to see that. How did you get 0? Niranjana, check that again, okay? Yes. Ma'am, shall we call someone and ask?
Sri Lakshmi.
Yes, Sri Lakshmi. Hi. Okay, still I can choose.
Headset remove
Like, have you connected headset? Can you please unplug it? Can you please unplug your headset and then talk? Unplug it from the phone. Yeah, you can unplug. Yes. Ah, yes, now I can hear you. So, tell me, what is the maximum number of electrons that can be accommodated in the M shell?
What, miss?
The maximum number of electrons that can be accommodated in the M shell. That is our third shell. Do you remember the formula that we said before? First rule എന്തായിരുന്നു? What was the first rule? ഒരു ഷെല്ലിൽ accommodate ചെയ്യാൻ പറ്റുന്ന maximum number of electrons is given by a formula. What was that formula? What was that formula here? Okay, so who wants to help Sri Lakshmi? Who is that one? The first one to raise her hand?
Anamika.
Yes, Anamika. Yes.
Ma'am.
So Anamika, what is... Yeah, tell me.
Ma'am, formula is 2n square.
Very good. The formula is 2n square. So when you substitute 3 here, what is the maximum number of electrons that you can accommodate in M shell?
18.
Very good. It is 18. Okay, perfect. So Sri Lakshmi. Yes. So നമുക്ക് ഈ ഒരു like formula ഒരു 3 times എഴുതി പഠിച്ചാലോ? Okay. Perfect. And you should send it to your class teacher, okay? All right.
Okay.
Perfect. Yes, it is 2n square, and that is how you like find the maximum number of electrons that can be accommodated in each shell. And I hope the first rule is clear for you guys. Now you can take it down, like note it down, okay? Yes. The maximum number of electrons present in a shell is given by the formula 2n square, okay? Where n is the number of orbit or number of shell. Very good. Very good, very good. Yes. And everyone, you are commenting. I can see the comments. Keep commenting like this, okay? Very good, very good. Yes. Now, shall we move on to the second rule? Before moving to the second rule, let's see a quick animation. Yes, sir. Our third animation. Okay, so imagine you are in a movie theater. Okay, movie theater. Just imagine that inside of an atom. Okay, it's just like a movie theater. Okay, yes, so you can play it. So here you can see that the first row. Okay, first row contains 2 seats. So the maximum capacity of the first shell, the shell. Okay, K shell, the maximum capacity is 2 electrons only. Okay, yes. Now, when you move on to the second row, that is our second shell. Okay, in our second shell, the shell can accommodate 8 electrons. Okay, 8 electrons. Now, the third shell, it can accommodate what? Like how many electrons? According to our formula, 18, a total of 18 electrons, then 32, and it goes on. Okay, yes, thank you, sir. Yes. All right, now let's move on to our second rule. Okay, what is our second rule? The maximum number of electrons that can be accommodated in the outermost orbit. Okay, outermost shell അല്ലെങ്കിൽ outermost orbital maximum accommodate ചെയ്യാൻ പറ്റുന്ന electrons in a number is 8. It is only 8. When we write the electronic configuration, or when you write the how electrons are distributed, the maximum number of electrons in the outermost shell will be 8. Why is it 8? Don't worry, we'll learn that. Okay, we'll study. Okay, yes. Srinidhi, which application? Can you please comment it? Yes. So the maximum number of electrons that can be accommodated in the outermost orbit will be 8. Okay, it is 8. Now, the last rule, which is our third rule. Okay, the electrons are not accommodated in given shell unless the inner shells are filled. Okay, അതായത് if this is the nucleus, and if this is the first shell and this is the second shell, first shell full maximum capacity fill ചെയ്തിട്ടുണ്ടാവും. The first shell should be filled, then only it will move towards the second shell. അല്ലാതെ first ഒരെണ്ണം ഇവിടെ first shell fill ചെയ്തിട്ട് second one ഞാൻ second shell കൊടുക്കാം. No, that is not possible. First shell completely filled down, then only the balance electron will go towards the next shell. Okay. Yes, അങ്ങനെ step by step ആണ് നമ്മൾ electronsനെ fill ചെയ്യുന്നത്. So when we do the problems, you'll get a more better idea. Okay. So is this three rules clear? You want me to explain the first rule, it seems, Srinidhi, right? Yes, you want the first rule. So Bohr said that we've got some shells inside an atom. അല്ലെ ഈ ഷെൽസിൽ അല്ലെങ്കിൽ ഈ ഓർബിറ്റൽസിലാണ് ഇലക്ട്രോൺസ് റിമൂവ് ചെയ്യുന്നത്, റൈറ്റ്? യെസ്. Now in order to find the maximum capacity of a shell, ഒരു ഷെല്ലിൽ മാക്സിമം എനിക്ക് എത്ര ഇലക്ട്രോൺസിനെ fill ചെയ്യാം? Okay, that is given, like that is found out using a formula. That formula is 2n square. Okay, the maximum number of electrons present in a shell is given by 2n square. And when you substitute the values, we'll get that K shell, which is our first shell. Okay, first shell n will be 1. So 2 into 1 square, that is 2. So the maximum electrons that can be accommodated in our first shell, that is our K shell, will be 2. Now, what about the second shell? Second shell accommodate ചെയ്യാൻ പറ്റുന്ന maximum electrons will be 2 into 2 square. That is 2 into 4, which is 8. Okay, it is 8. So that is how you find out the maximum number of electrons that can be accommodated in a shell. All right? Yes, very good, very good. So there are the three rules. Now, since we have studied the all three rules, shall we learn how to write the electronic configuration of some atoms? Shall we? So before that, when we studied our third chapter, I asked you to study the first 20 elements. Do you remember? And I also gave you a code. So, who will tell me the first 10 elements in the order? Correct order. First 10 elements in our Who wants to answer? You can raise your hand. Ah, very good. I think Fatima is the first one to raise her hand. Yes, Fatima. You can unmute. Hi.
Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon.
Very good, very good, very good. So first 10 is done. Now what about the rest? 11 to 20. Who wants to answer? Yes, ma'am.
Vishnupriya.
Vishnupriya wants to answer this question. All right. Now, tell me.
Sodium, magnesium, aluminium, silicon, sulfur, fluorine, neon, sodium, magnesium.
Do one thing. Slow down. You missed out an element. Okay. From sodium onwards. Yes, sodium. Sodium. Yeah. Come on.
Sodium, magnesium, aluminium, silicon, sulfur,
Silicon after silicon.
phosphorus.
After silicon. Silicon. After silicon we have. You can unmute. Okay. Please unmute. Yes, Kevin. Yes, I'll reply. Wait a minute. Okay. Yes. Yeah. Hi. Yes, Vishnupriya. Okay, Vishnupriya is commenting instead. Okay, it is sodium, magnesium, then what? Aluminium, silicon, phosphorus. Okay, phosphorus and then sulfur, then chlorine, argon, then potassium and calcium. Okay, yes. Now Kevin asked me a question. Ma'am, can I see that? Yes. What is a force stopping the electrons to overfill? Now, we already studied that electron has got what? A negative charge. So, when the number of electron increases, there will be strong repulsion. Okay. It is a charged, electron is charged species. So when two negative charges, when they come, like I'm going to fill it, when they come closer, there will be strong inter-electronic repulsion. Okay, because they are of same charge. So there will be repulsion between the electrons. Okay, I hope it's clear now. Yes, so we are going to write write the number of how these electrons are distributed in different shells. That's electronic configuration. Okay, we call it electronic configuration. Now, the first element that we are going to write is hydrogen. Okay, hydrogen is our very first element, and inside the hydrogen atom, it only has one electron. Okay, hydrogen in the electron, how many electrons? It is one electron. Okay, now since the hydrogen has only got one electron, it will occupy the first shell, right? Yes, so you can draw a nucleus first. Okay, you will first draw a nucleus and you will draw our first shell, which is our K shell, and you can represent your electron like this. Now you have to study how to draw Bohr's model. Okay, this is for hydrogen atom. Is it clear? Hydrogen has got one electron. Okay, one electron. Now, let me ask you, we studied that atom as a whole is electrically neutral, right? Now, if it has got one electron, how many protons will it have? How many protons will it have? Yes, very good. All of you are showing this. Okay, yes, you are right. It is 1. Since it's neutral, etra negative charge undo, atra thanne positive charge undo, right? Yes, so it will have 1 proton. Now, we studied about neutrons, right? Neutrons we said that എല്ലാ atoms, there are 3 subatomic particles. We have proton, neutron and electron. Now, hydrogen is the only atom which does not contain a neutron. Okay, is it clear? Hydrogen is the only atom which does not contain any neutron. Okay, hydrogen in the neutron. Now, what happened, Adil? Adil, answer don't worry, I'll call you. Okay, yes. Okay, so this is how electrons are distributed for hydrogen. Now, the second element is helium. How will you represent helium? What is the symbol of helium? Everyone in the comment box. in the comment box. Very good. Helium is represented as He. Now, helium has got 2 electrons. Okay. Helium has 3 electrons and a total of 2 electrons. Alright. Now, how will you draw the Bohr model for helium? First, what you should do is you should draw a nucleus. Okay, draw a nucleus. Then you will draw the first shell, which is our K shell. Okay, the first shell. Now, helium has 3 electrons and we have 2 electrons, right? Now, what is the maximum capacity of the K shell? It is 2 only. So, our 2 electrons will accommodate you in the first shell. So, you can represent it like this. Represent it like this. Is it clear? This is how you draw the structure of helium. Okay? Yes. What is the thing that hydrogen doesn't have? It is neutron. Okay? Yes, neutron. Very good. Now, this is how you represent what? Okay. Yes. Very good. It is how you represent helium. Now, instead of, yeah, it's okay, yes. Who is it? Evelina. Evangelina. Yeah, okay, it's okay. Now, this is how you should draw it if they ask to draw the electronic like representation or schematic diagram of helium. Now, sometimes they will ask you to write the electronic configuration. Okay. When they are asked like that, what you should do is, you know, it is helium is represented as He. The electronic configuration of He is, there are a total of 2 electrons and the first shell is the K shell, right? Yes, in the K shell, there will be 2 electrons. This is how you write the electronic configuration of helium. Now, how will you write the electronic configuration of hydrogen? What about hydrogen? Hydrogen is H and there is only 1 electron in hydrogen. Okay, hydrogen, it has only got 1 electron. So you can write that in K shell, 1 electron. Okay, is it clear? Yes. Now, next one is lithium. Okay, next element is lithium, which is represented as Li. And lithium has got 3 electrons. Okay, 3 electrons. Now, how will you draw the structure? First, as usual, draw the nucleus. Okay, you should draw the nucleus first. Then what you will do? Then you will draw the first shell, which is the K shell, right? Yes. Now, what is the maximum capacity of K shell? It is 2 electrons. So, draw the 2 electrons here. Okay, but we have 1 more electron. Alle, one electron kuda undu. Adu njan enginengil adjust cheyidittu ivide thanne ezhudiyalo. No, that is not possible. Okay, so that electron will go to our next shell, which is our L shell. Which is our L shell. This is how you draw the structure of lithium. Is it clear? Is it okay? Yes. Now, how will you write the electronic configuration? How will you write the electronic configuration of lithium? Lithium is represented as Li. And we have K shell. In K shell, 2 electrons will be filled. And balance one electron that will go to the L shell, right? L shell. So the electronic configuration of lithium is 2,1. So if they ask the lithium, like electronic configuration of lithium, you can write it as 2,1. Okay, 2 electrons in the K shell and 1 electron in the L shell. Very good. So now it is question time. Okay, let me ask some questions. The next element is beryllium. Now, I want you to draw the structure for beryllium atom, and I'm telling you beryllium has got a total of 4 electrons. Now, quickly draw the structure. And Miss Orala Vilikam, so just show me your notebook, okay, towards the camera. Alright, Yes. Can we also write 3? It is 2 comma 1. Okay. 2 comma 1. First shell 2 electrons and the remaining in the L shell. Okay, Devanarayanan. When they ask the electronic configuration, write 2 comma 1. Yes. Done. Kevin is done then. Yes. Joel, what happened? What is your doubt? You can comment it in the comment box. Okay. Yes. So Adil, done. Yeah. Can you show me a notebook? And also write the electronic configuration. Okay. You can draw the structure and also write the electronic configuration. Yes. Yes, Adil. Where is Adil? Adil is not here, it seems. There. Ma'am, can you just pin that? Who was that? It's Adil only. Yeah, can you just pin? Yes, very good. It is correct. It is correct. Okay. Yes. So others, do you have any doubt? Joel, what was your doubt? Can you please comment your doubt? Okay, it's okay. Gia. Yeah, Gia, can you please raise your hand? Let me check it. Ma'am, you can. Yes, where is Gia? Can you please show me your notebook, Gia? Yeah. Yes, ma'am. Oh, it is perfect. Okay. Okay, perfect. But when you write the configuration, you can write it like this. Okay. Yes, the structure is correct. Okay. Now, it is beryllium. Beryllium has got a total of 4 electrons, right? So, 2 electrons in the K shell and in the next shell, 2 electrons. 2 comma 2. You can write it like this. Okay. 2 comma 2. K shell 2 electrons, L shell 2 electrons. Write the electronic configuration like this. Okay. Yes, perfect. So it's easy, right? Yes. Now, yeah, this is how you drew you can check it. Okay, this is how you drew the structure for beryllium atom. There is a nucleus and in the first shell you've got 2 electrons and in the second, like the balance electrons will move towards the second like shell, right? Yes, it's clear, I hope. Now, quickly draw the structure of boron. Okay, boron. I'm telling you, boron has got 5 electrons. Boron has got 5 electrons. Yes. Boron has got 5 electrons. Now, how will you draw the structure? Yes, it is like this, right? The first 2 electrons will go towards the first shell and the remaining 3 will go in the second shell. So, what is the electronic configuration of boron? It is 2, 3, right? Yes, in the K shell 2 electrons and L shell 3 electrons. Very good. Who is that, man? Devanarayanan. Yeah, very good, very good. It is 2, 3. Yes. Everyone, I'm seeing it. Okay, yes, very good. Now quickly draw the structure of carbon. Carbon has got 6 electrons. Carbon has got 6 electrons. They'll ask, like in the exam, to draw the structure. Okay, yes. Draw the structure and also write the electronic configuration. Okay. Oh, is it? Nice. I have a wallpaper set to periodic table. Alright. Yes. Very good. The configuration is 2, 4. And did you get the structure? Did you draw the structure? 2 electrons in the first shell and the remaining 4 electrons in the second shell. And the electronic configuration of carbon is 2, 4. Very good. Now, let's move to the next one. After carbon comes nitrogen, right? Yes, so draw the structure of nitrogen. Nitrogen, everyone. Nitrogen has got how many electrons? Any idea? 7. Okay, it has got 7 electrons. Yes, and we'll call, let's call Avani to answer the question. Okay, yes. Yes, Avani, can you please raise your hand? Yes, Avani. Hi. Hi, Avani.
Hello, ma'am.
Yeah, so, yes, good evening. So, quickly tell me the electronic configuration of nitrogen.
2,5.
Very good. It is 2,5. And this is the structure, right, of nitrogen atom. Yes. This is how you schematically represent it. Very good. Very good. Now, let's move. Yes, very good. Let's move towards the next one, that is oxygen. Okay. Now, oxygen has got a total of 6 electrons. Okay. No, not 6. Sorry. 8 electrons. Okay. Oxygen has a total of 8 electrons. So what will be its configuration? K shell. Oxygen will have 2 electrons in the K shell and 6 electrons in the L shell. Okay. Yes. You can take a quick screenshot now. Okay. Yes. And it's also given in your textbook. Yes. Now, the next one is fluorine. Okay. Next one is fluorine. Now, what is the electronic configuration of fluorine? It has got 9 electrons. Okay, fluorine has got 9 electrons. So, I can write that the electronic configuration for fluorine will be 2 electrons in the first shell and 7 electrons in the next shell. Okay, that is the L shell. So, 2,7 is the electronic configuration. Now, the next one, okay, next one is neon. Okay, neon. Now, neon has got a total of 10 electrons, guys. Okay, 10 electrons. Now, how will you write the electronic configuration? First shell, 2 electrons, and then in the second shell, very good, it is 8 electrons. It is 8 electrons. Now, the next one is sodium. Okay, when you write the electronic configuration of sodium, it has got 11 electrons. Okay, it has got 11 electrons. So, how will these electrons get filled? Let's see. Sodium is Na, right? In the first shell, it will have 2 electrons. Okay, first shell will have 2 electrons. Then, in the second shell, 8 electrons, right? 8 electrons. Now, balance നോക്കിക്കഴിഞ്ഞാൽ ഇപ്പോൾ 10 അല്ലേ ആയുള്ളൂ. There is one more electron, right? It will go to the next shell, that is our M shell. So, the electronic configuration of sodium is 281. Why? Because in the second shell, the maximum capacity is only 8. Okay, maximum accommodate ചെയ്യാൻ പറ്റുന്ന electrons എത്ര? It is only 8. That is why the last electron went towards the next shell. Is it clear? Okay. Yes. Now, it is not 128 or 218. ഇങ്ങനെയൊന്നും അല്ല നമ്മള് സോഡിയത്തിന്റെ electronic configuration എഴുതുക. Okay, the first shell, it should be completely filled first. Then only it will move towards the second shell. Okay, second shell fill it. When it reaches its maximum capacity, it will move towards the third shell. So, what is the electronic configuration of sodium? It is 281. Okay, 281. Okay, so can I give you a homework for you guys? Can I give you a homework like after this question? Okay, now quickly write the electronic configuration of magnesium. Okay, Magnesium. Everyone. Magnesium has got 12 electrons. Magnesium has total of 12 electrons. Just you can comment it in the comment box. Notebook illa, just in the comment box. Very good. 12 electrons are, so it is 282. Okay, it is 282. Now, what you should do is you should write the electronic configuration, and also you have to draw the structure for aluminium, silicon, phosphorus, sulfur, chlorine, and then argon. Okay, argon. Now, aluminium has got 13 electrons, silicon 14, phosphorus 15, sulfur 16, chlorine 17, and argon 18. Will you do it? Yeah, will you do it? Yes, this is a homework. Okay, you can take a quick screenshot. Okay, you can take a quick screenshot and write the electronic configurations, and also you should draw the structure. Okay. Yes, schematically you should represent these atoms. Okay. Alright. So we are moving on. Okay. And our next topic, it's not topic, it's, yeah, we'll come back to this. Okay, don't worry. Yeah. So, ever seen this before? This is nothing but our periodic table, right? Yes, you can put on your pen now. Just relax and hear me out. Yes. Now we are talking, we are going to talk about an interesting topic that we've already covered in our third chapter, and that was valency. Okay. It is valency. Sir, is there any technical error? Yeah. It is valency. Now, what was valency? Valency, do you remember it? Valency endaayirunnu? Any idea? You can comment it in the comment box. Someone is like, ma'am, valency, I haven't heard that before. Really? So, valency is nothing but the combining capacity of an element. Alle? One element in the combining capacity in the valency. Now, how is this element combining with the other element, or why is it reacting? Okay, yes, we should study about that first. But when you take a closer look in the periodic table, you can see there are, let me change the color of the pen. Okay, we've got 18 vertical columns. Okay, we've got 18 vertical columns. These 18 vertical columns are called as groups. Okay, what is it called? Groups. This is the first group, then we have the second group, then the third, fourth, and it goes on. And we have group number 18 at last. Okay, now I want you to focus on here, the group number 18, which is our last group. Okay, the first element here is, you cannot see because of that logo. So can we just remove that? Is it possible to remove that logo? This one? No, it's okay. So it is helium. Okay, this is nothing but He, that is helium. Except helium, all other elements, that is neon, argon, krypton, xenon, radon, okay, they all have got 8 electrons in their outermost shell. Okay, listen to me carefully. They have got 8 electrons in their outermost shell. Now, helium is an exception. Helium has got 2 electrons. Only one shell, and it has got 2 electrons in that shell. Okay, yes. Rest of them has got 8 electrons in their outermost shell. And these 18 group elements, they are found to be chemically inactive. Okay, reactions they are not participating. Okay, why? Because when they have got 8 electrons in their outermost shell, they are found to be stable. Okay, They are found to be stable. So what other atoms are doing is that somehow they they want to get the 8 electrons in their outermost shell. Okay, എങ്ങനെയെങ്കിലും reaction നടന്നിട്ട് they want to be like the group 18 elements. Now these group 18 elements is called noble gases. Okay, they are noble. Noble means they are not chemically reactive. Okay, so other rest all of them want to be like noble gases. Why? Because they want stability. Okay, avarku stability venam. So they will somehow try to attain what noble gas configuration. Okay, yes. Okay, all right. Now read this. Okay, an atom is stable if it has got a hi, yes, hi Nimi, hi, yes. An atom is stable if it has got a duplet or octet configuration. Now what is duplet or octet? Yes, we said that helium has got an outermost electron of 2. Now the outermost electrons found in helium is 2, right? Yes. 2 ആണെങ്കിൽ we call it as duplet configuration. Okay, that is only for helium. ഹീലിയത്തിന് മാത്രമാണത്. Okay, rest all other atoms, they will somehow try to attain 8 electrons in their outermost shell. Okay, അവർ എന്ത് ചെയ്യും? outermost shell 8 electrons എങ്ങനെയെങ്കിലും achieve ചെയ്യും. Okay, since it's 8, that is why it is called octet configuration. Okay, octet configuration. This duplet is only for helium. Okay, it is for helium. And hydrogen will also try to, hydrogen has only got 1 electron. Okay, 1 electron no koodale hydrogen two duplet configuration possible aayitullu. Yes, it has only got a single shell, and the maximum number of electrons that can be accommodated in that shell is 2. Okay, yes, rest all other elements will rest all other elements will try to attain an octet configuration. Octet configuration means 8 electrons in the outermost shell. Okay, outermost shell. Now പറഞ്ഞു that group 18 is known as noble gases. അല്ലെ, noble gases. അപ്പൊ noble gasന്റെ പോലെയുള്ള configuration എന്നുള്ളൊരു മീനിങ്ങിൽ we call these configuration as noble gas configuration. Okay, so ബാക്കിയുള്ള ആൾക്കാരൊക്കെ somehow they are participating in the reaction to what? To attain a noble gas configuration or octet configuration. So, if in their outermost shell, if it is 8 electrons, it is found to be stable. Okay, that atom is found to be stable. Is it clear? Or do you have any doubt? Okay, all right. Now, the next topic is valence electrons. Okay, what are valence electrons? Onnulla. This is the, let me see. This is sodium, right? Let's write the electronic configuration of sodium. What was it? It was 2, 8, 1. Okay, 2, 8, 1. This is the K shell, this is the L shell, and this is the M shell. Now tell me, which is the outermost shell? K, L or M? Which is the outermost shell? Nucleus കഴിഞ്ഞിട്ടുള്ള first shell is K, then comes L, then comes M. Very good. M is the outermost shell. Now, how many electrons are present in the outermost shell? It is 1. Okay, so what is valence electron? It is the electrons present in the outermost shell of an atom. Okay, so sodium in the valence electrons etraya? What is the valence electron of sodium? Find the outermost shell and find how many electrons are present in the outermost shell. It is 1. Okay, it is 1. So, now what about magnesium? The electronic configuration of magnesium is 2, 8, 2. So, how many valence electrons does magnesium has got? It has got, very good, 2. Now, what about oxygen? Oxygen. The electronic configuration of oxygen is 2, comma 6. Now quickly tell me the valence electrons. Yes, very good. It is 6. Now is it easy to calculate the valence electrons? Pretty simple, right? Yes, it is 6 valence electrons for what? Oxygen. Now, I said that except the noble gases, what others are doing? Others are somehow managing to get a configuration just like these noble gases. That last the shell, somehow it should get 8 electrons. Now, how will it do? Okay, how will it attain a noble gas configuration? Either it can give its electron. Okay, for example, sodium has got 2, 8, 1. This is the electronic configuration of sodium, right? Yes. Now what sodium will try to do is, outermost shell, it should reach 8 electrons. Now sodium has got 2 ways. Okay. First way is to accept 7 more electrons. Okay. It can either accept 7 more electrons so that in the last shell it will become 1 plus 7, which is 8. Okay, can accept 7 electrons. Or there is another option for sodium, easier option. Last shell, 1 electron. It has only got 1 electron in the last shell. Just remove or lose that electron so that it will get 2, 8. 2, 8 or a configuration. Okay, so accepting 7 electrons or just removing that 1 electron present in the outermost shell, which is easier? What do you think? Which is easier? Accepting 7 electrons or just removing 1 electron? So what atoms will do is, either in order to get the stable octet configuration, either they will lose electrons. Okay, either they will lose electrons or they will gain electrons, or they can even share electrons. Okay, share electrons. This will give an idea about the combining capacity of an atom. Okay, we call it valency. Okay, so what is valency? Valency is nothing but the combining capacity of an element, and it gives us an idea about what? About the reactivity of an element. How reactive is that element? Since it has got, just read the definition first and then we'll come back to it. Okay, valency is nothing but the number of electrons gained, lost or shared by an atom of an element. Why are they gaining or losing or sharing these electrons? In order to get a stable octet configuration. Okay, stable octet configuration return. What will these atoms do? They will either lose some electrons or they will gain some electrons or they will share some electrons. Valency. Okay, is it clear? Is valency and valence electron bit confusing or is it clear? In the comment box, everyone. Is it clear or do you have any doubt? Okay, it's clear. Very good, very good. So if this is clear, now in the question, they'll ask you to find the valency of certain elements. Now let's quickly check how to find the valency of element. Now the valency of element having 1 to 4 electrons in the outermost shell. Okay, if the number of electrons in the outermost shell is 1 to 4, the valency will be equal to the number of electrons present there. Okay, number of electrons present there. Put down your pen, no need to write. Okay, no need to write. I'll explain it using an example. Okay, let's take magnesium. Magnesium. What is the electronic configuration of magnesium? It is 2, 8, 2. Right? It is 2, 8, 2. Now, look, the valence electron. It is, what is the valence electron? The number of electrons present in the outermost shell. Outermost shell, it has got 2 electrons. Okay, so the number of electrons, if it is 1 to 2, 1 to 4, okay, if the number of electrons is 1 to 4, the valency of that atom will be equal to the number of valence electrons. Okay, since it's 2, I can say that the valency of magnesium is what? Is 2. Okay, valency of magnesium is 2. Now, what about sodium? Sodium is 2, 8, 1. Valence electrons, it is 1. Okay, it is 1. So, since it is 1, the valency will be equal to what? The number of valence electrons. So, I can say that the valency of sodium is 1. Okay, valency of sodium is 1. Now, what if that atom has got more than 4 electrons in the valence shell? Yes, let's find it out. I'll give you an example. It is oxygen. Okay, the electronic configuration of oxygen is 2,6. Okay, it is 2,6. So, in this case, what you do is you have to subtract the valence electrons from 8. Okay, 8 minus the number of valence electrons. So, let's find out the valency of oxygen. How will you get it? 8 minus, yes, 8 minus, what is the number of valence electrons for oxygen? It is 6. What is 8 minus 6? That is equal to 2. Okay, 8 minus 6, that is equal to 2. Okay, very good, very good, very good. Keep commenting. Now, one more question. What about fluorine? Fluorine. How to find the valency of fluorine? The electronic configuration of fluorine is 2,7. Okay, it is 2,7. Now, quickly comment the valency. Very good, very good, very good. Yes. Yes. It's not 7. 7 Allah. How will you get it? How will you get it? If the number of electrons is 5 to 8. Okay, what you should do is 8 minus the number of valence electrons. So, in order to find the valency of fluorine, yes, very good, very good. What you should do is 8 minus 7, that is equal to what? 1. So, I can say that the valency of fluorine is 1. Okay, is it clear? Now, another question, carbon. The electronic configuration of carbon is 2,4. What is the valency of carbon? In the comment box. Very good. It is 4. Valency of carbon is 4. Okay. Yes. So, simple topics. We learned how to write the electronic configuration. Before that, we saw Bohr's model and we saw valency. Okay. Yes. Shall we go and attend the exam? So today's exam is an easy peasy exam, guys, and I'm sure all of you will score 10 on 10. Okay. Yes. So it's time to say goodbye to the YouTube family and my Zoom students. You should not go. Okay. Please remain in the class. All right. Yes. You can quickly go through what we've learned. Okay. Easy questions, Anna. Do not forget to attend the exam, okay? You should attend the exam, then only you can evaluate yourselves, right? Yes, so just quickly go through what we've learned. Yes. Okay, so it's time to say goodbye to the YouTube family. Thank you so much for joining today's class and see you in the next class.